Oh, greetings everybody. Let's have a look at this problem that is, at least at the time I'm making this video in this particular semester, from assignment 2.3. We're given a function that tells us the pH of a person's mouth in terms of the minutes after they eat something. So when I look at this graph, even though this function might seem complicated to look at on its own, the graph seems to tell us something pretty simple, that naturally the pH of your mouth might be like 6.5, okay? And then you eat something and it drops fairly rapidly and slowly climbs back up to what looks like normal, okay? So in terms of the assignments that you'd be working on with this problem, it has a horizontal asymptote right there, okay? As the pH tries to climb back up to normal after you eat something, after this rapid dip. Okay, so we're going to look at this graph and possibly examine this function a little bit and answer these questions. Okay, so first it says use the graph itself to get a reasonable estimate of the pH 24 minutes after eating a food containing sugar. So I'll look at it a little bit closer, and on the horizontal axis is time, minutes after eating, and on the vertical axis is pH. So I can see 24 right here. That would be 24 minutes after eating, and then that, whatever that number is vertically, over here, that would be what the pH is. So let's see, 4.5, 4.6, 4.7, 4.8. All right, so at 24 minutes, we're at a pH of 4.8 just looking at this scale. All right, so we'll put in our answer like so, and then check it, and it works. Okay, so next it says after eating sugar, when is the pH level the lowest? Use the function's equation to determine the pH level at this time. So what I see here is that I can look at the graph to see when it's the lowest. Okay, so I said that you eat something and the pH level in your mouth dips fairly rapidly and gets at a minimum here, whereafter it begins to climb back up. So this is the point that they're asking about. Okay, all right, that would be at the 12-minute mark. And so what I would have to do according to this question is, using the function's equation, determine what the pH level is at the 12-minute mark, meaning when x is 12. You see, x is the minutes after eating a food containing sugar. So I gotta put in 12 into this function and see what I get. Now for that, I'm gonna plug in my drawing tablet so I can write something down, but in order to do that, I'll pause the video real quick. Okay, so now I have my writing tablet up. And as I mentioned, I identified 12 as the x value of interest on the graph, and I would just need to figure out what is this function when you let the x be 12. Here's what that would be. Notice I just put 12 in for the x, and it's a matter of calculating. When I did this just now, I used my handheld calculator. When you use your calculator, sometimes calculators are very sensitive about the order of operations. You may need to put parentheses around all that stuff on the top, then press divide, then put parentheses there like I have in red around the stuff in the bottom, okay? Just to make sure that you are getting your calculator to do what you want it to do. So I get 4.372, and let's see. First of all, when it says the pH level is lowest after how many minutes, then that's 12. That's the number I identified on the graph. Okay. And then the pH level at that time, where it says round to the nearest tenth, okay, that would be 4.4. See, I get 4.372. Rounding to the nearest tenth would be rounding to that decimal place right there. So 4.37 becomes 4.4. So that's the pH. That's as low as it gets before it starts to rise back up to normal, which seems like it's about 6.5. Okay. All right. According to the graph, what is the normal pH level of the human mouth? Well, remember when I looked at this earlier, I said, well, my impressions of it are that, you know, at time t equals 0, when you haven't eaten anything yet, it says your pH is about 6.5, right? So that's where it starts off, and then it takes this rapid dip after eating, but it's trying to climb back up to normal as time goes on, okay? So that's what you're seeing here. And there it is, 6.5. That green dashed line, the horizontal asymptote of the graph, is what appears to be normal. All right, so that's what we're looking for part C. Okay. All right. And it says, what's the equation of the horizontal asymptote associated with this function? Well, I did mention that the interpretation of this horizontal asymptote, this horizontal line that the graph is trying to climb back up to, is the normal pH of the human mouth, okay, without having eaten anything. So the equation for that, you know, 6.5 is a number, it's not an equation. You know, I can say 6.5 is the normal pH level of the human mouth, but for me to give you an equation of a horizontal asymptote, that'd be the equation of this horizontal line, that line that's dashed in green right there. The equations of horizontal lines always take the form y equals a number. So the horizontal line that goes through 6.5 on the y-axis would have the equation y equals 6.5, okay? So 6.5 is a number. It's the number that it's the normal pH of a human mouth. And the equation, according to this graph that tracks the pH after you eat, the equation of the horizontal asymptote of that is y equals 6.5, okay? All right. So in a way, they're the same thing, 6.5 being the normal pH and the horizontal asymptote being y equals 6.5. In a way, they're the same thing, but they're technically different. One's a number, one's an equation on the graph. So what does this mean in terms of the mouth's pH level over time? Well, what did I mention? You know, I said it a minute ago, it's like it takes this rapid dip after you eat, but it slowly tries to climb back up to where that green dashed line is, okay? So I think the way to say that in the context of this last question is C, the mouth's pH level over time gets progressively closer to the horizontal asymptote. That's why that horizontal asymptote is an important feature of the graph, okay? So that's what we want for part D. And then after that, we've done our full interpretation of what this equation tells us, along with the graph that comes with it.